B, we get the natural log of A equals M, or X rather is T, M is negative K, put that together, you get negative KT, plus B, which is the natural log of the initial concentration of A, which we call A sub 0. And this is the equation for first order reactions. We can plug in all the information we have and we can predict how much concentration we're going to have over a certain period of time at which this gets run or gets observed. And then, but we have to have the value K. Well, how do you get the value K? Well, we just did that. We just run some experiments and find the value K when we find the order, blah, blah, blah. We know it's a first order reaction. Based upon what we saw like in that first problem, that was definitely a first order reaction. And then we can figure out the K from substitution in those equations, and boom. Plug in K, we know the beginning concentration, and we know the amount of time we want to observe it for, whatever that is, and there you have it. Okay, so this is going to be a very important equation in your chemistry toolbox. All right, so let's take a look at a couple of problems here to reinforce that. Let's take a look on page 641, problem number 49. So we've got sulfuryl chloride, which is SO2Cl2. And it says that the initial concentration of that, so that's concentration of SO2Cl2, sub-zero is 0.0248 moles per liter. And it says the rate constant, so that's our K, and that is 2.2 times 10 to the negative fifth seconds to the negative 1. Again, I prefer that method than the /s, same thing. What is the concentration of SO2Cl2 at 2 hours? And this is the reaction's first order, which is good to know because we haven't done second order yet. We wouldn't be able to do it until second order. So now, we need to find out what we have, what we don't have, and what we need to do in order to finish this problem. So the equation again is concentration of this, instead of saying A, I will now say SO2Cl2 is equal to negative KT plus, sorry, that's the natural log of that concentration, plus the natural log of the concentration of SO2Cl2 initially at 0 seconds. Now notice I said the word seconds. We generally find rate of reaction in seconds. So we gotta move this thing over here to seconds. If you know anything about hours, that 1 hour is 3,600 seconds. We multiply this by 3,600 seconds per hour, and we get 7,200 seconds. So that's our time. And this is our unknown right there. That's what we're trying to find out. What the heck is this right here? Okay, so let's start plugging in numbers that we got up here. So, natural log of SO2Cl2 equals, let's move this up a bit so we might be able to see it better. Negative K, we said K is 2.2 times 10 to the negative fifth. So this is a negative 2.2 times 10 to the negative fifth seconds to the negative 1 times the time, which is 7,200 seconds, plus the natural log of the initial SO2Cl2, which we said is 0.0248. So So the only unknown is over here, so we ought to just get our calculators and just solve that based upon what that says. So negative 2.2 e negative 5 times 7,200 plus the natural log. ln is right below the log button here. Parentheses should pop up automatically, 0.0248. Close parentheses if you wish. You don't have to at the end of the problem in this case. And I'm gonna give 3 decimal places on this one. Because you got logarithms, they tend to be really different if you only have like 1 or 2 decimal places. So we go to 3, it tends to be a little more close to what it should be. But now we got our serious issue here. How do we get rid of that natural log symbol? Well, the log key in your calculator is a base 10 value. In other words, the exponent, first of all, the word logarithm means exponent. It's a synonym for exponent, and I know that many of you have been doing logarithms and really had no idea what you were doing, what it all meant. You're just performing, functions, performing an act, if you will, for doing a math problem and not really knowing why. It's all about exponents of 10 and all the rules about multiplying 2 bases like, 2 like bases with exponents. You add the exponents, you divide them, you subtract them. It's all the same rules as exponents here. That's what we've got going on right here. Natural log, however, is not base 10. Natural log is based upon what they call the natural number, also known as Euler's number. And Euler is spelled E-U-L-E-R. So they gave the symbol for Euler's number, or the natural number, as a lowercase e. And when you take e to that, because this is logarithm, this is saying e has a logarithm of this value. So we take e caret to both sides, so we keep it equal. But this cancels out your logarithm by definition. And this becomes the concentration of SO2 Cl2. And then we hit second ln, and you get a little e caret in the parentheses, then you just plug in negative 3.855. And we get 0.0212 moles per liter, going back to the 3 significant figure rule for our final answer. And that's how you do a problem like that. Y equals mx plus b is a powerful tool. Powerful tool. If we can turn any curve into a straight line, that makes life easier. Now your calculator does that for you, but I want you to understand that's why you have all these options in your calculator for coming up with values, and they give you different types of equations. Well, one is logarithm, and there's hyperbolic. There's all kinds of equations or setups for equations that allows you to use y equals mx plus b. They've all been modified to resemble y equals mx plus b. Well, they just don't show you. They just say, I'll do it for you. You just sit here, put yourself down. Done. But this is how it's done. Let's do one more. Let's take a look at problem number 51.